Hello guys, welcome again to this video. So as discussed in the previous chapter, we are trying to do gamma function here, and what we had proved in the previous chapter is as follows. I will just write down the values and whatever findings we made in the last video as follows. So firstly, we defined function as follows. And we defined it for natural numbers, right? So gamma of n is 0 to positive infinity integral e to the power minus x to the power n minus 1 dx. This was gamma of n. Now what we had proved is as follows. Is that gamma of n is equals to n minus 1 into gamma of n minus 1. So we saw that the gamma function can be defined recursively like that gamma of n is basically n minus 1 times gamma of n minus 1. Now if you continue this recursion, we will have a systematic way to evaluate the value of gamma n from this recursion. But if we were to continue this recursion, this would end at a certain point where gamma of 0 would be encountered, gamma of 1 would be encountered, right? So it's better that we already find out the value of gamma of 1 beforehand. So gamma of 1 would be exactly this expression, right? Now x to the power 0 is just 1, so it will be 0 to positive infinity e to the power minus x dx. Now if we were to evaluate the antiderivative of e to the power minus x, which is minus e to the power minus x from 0 to positive infinity, so it will be minus e to the power minus infinity plus e to the power 0, which is just 1 because e to the power minus infinity is just 0. Okay, so this is gamma of 1. Now from the recursive definition, right? So what we can do is as follows. We can use gamma of n by gamma of n minus 1 equals to n minus 1, right? And now we can take different values of this left hand side expression and multiply them together, because what happens is they are a telescopic product, and when a telescopic product happens, what you do is it cancels off half of the terms, and what you're left with is only two terms. So it cancels all but 2, and those 2 terms will give you your answer. Basically what I mean is this: if you were to do an infinite product here, for gamma n by gamma n minus 1, and same thing on the right hand side for some natural number k up to some natural number k, right, where k is greater than or equal to 2. What would you get on the left hand side? So starting from 2, let us do this. Gamma 2 by gamma 1 would be the first term. Next term would be gamma 3 by gamma 2. The next term would be gamma 4 by gamma 3, like that, and the last term would be gamma k by gamma k minus 1. Observe this carefully, what I have done here. Take a moment to realize how this sum actually cuts itself off. Well, on the right hand side it would be obviously from 2 to k minus 1, which is like from 1 into 2 all the way up to k minus 1. And you see this gamma 2 and this gamma 2 cancels off, this gamma 3 and this gamma 3 cancels off. Similarly, this gamma 4 will cancel off with the next part. Similarly, this gamma k minus 1 will cancel off with the numerator of the previous expression, right? What will be left is gamma k and gamma 1. So what we will have is gamma of k by gamma of 1 equals to k minus 1 factorial. Therefore, gamma of k, since gamma of 1, as we had evaluated earlier, is just gamma of 1 into k minus 1 factorial, which is just k minus 1 factorial. So this is the definition of gamma of k for natural numbers k, okay, and basically this also is valid for k greater than or equal to 1, because gamma of 1 by this definition is 0 factorial, and 0 factorial, as you know, is 1. So therefore gamma of n is n minus 1 factorial for all n belongs to natural numbers n. So this much is clear, right? Now since we were very much keen on developing this formula for natural numbers, we might as well understand how to extend it to the real numbers and the complex numbers, and then we shall proceed. So what we cannot do in case of real numbers is just evaluate it in terms of factorials. That is not possible. But well, obviously, natural number or not, the definition still works, because since this happens, and this is the representation, irrespective of where n is a natural number or not, by IBP we still have n minus 1 into 0 to infinity, positive infinity, x to the power n minus 2 into e to the power minus x dx, which will give you n minus 1 into gamma of n minus 1, right? So this basically works. So what we do understand here is that, well, as long as we have n being a real number, we can still use this definition, and obviously this might not end, but still we can find a way to find all the real numbers n such that gamma of n is defined. So what it thinks here is that for s greater than 0 and s belongs to reals, gamma of s, which is equals to 0 to positive infinity, x to the power s minus 1 e to the power minus x dx converges. So this is basically the theme. So this would imply that the gamma of s basically converges for all real numbers, and this is also true for complex numbers as well. We shall go that into it a little bit later into this lecture series, but for the next part we shall see how different properties of gamma work, how to do them, and how do we proceed with this kind of definitions, and specifically to find the value of gamma of half. So we shall see you in the next video. Thank you for watching. So please download the Breatter Maths app, which is given in the description. It is a mathematical app where you can find all the necessary statistical calculators like chi-square calculator, one variable means, population means, t-value, and much more. You can also find calculus related calculators like integration, derivatives. There is a section where you can find what's coming up next. There is a section completely devoted on mathematical notes where you can find notes on probability, statistics, calculus, and many more are there to come. In those notes we have already explained all the examples, all the problems and theory, and we are just covering the video lessons and solutions of those here. You can check that out. Also you can see the video solutions in a separate section where you can understand and give a feedback on what to expect next. You can ask for a problem, you can ask for a theory section as well. So please do check it out, and also do subscribe to Breatter Maths app and also its YouTube channel.